Now, in this question it says, when an ideal gas undergo unrestrained expansion, no cooling occurs because the molecules. Now, the reason over here is that when we talk about ideal gas, we say that they are point masses, point number one. And second, we say that there are no intermolecular forces. So, when there are no intermolecular forces, so a molecule does not exert any kind of influence on the second molecule. We will have to understand that they exist independently. A molecule of an ideal gas does not affect a second molecule. Now, when we say unrestrained expansion, which means, let's say we can take example of expanding against a vacuum. We had this cylinder and this was the piston, and on one side we had vacuum, and then if we release it, so it will be a kind of a unrestrained expansion. So generally what happens when gas does work, so because the gas will have to do some work to push this piston if there was some pressure which was opposing it, right? And that work is done at the expense of kinetic energy of the particles. तो जब ये गैस काम करेगा तो उससे क्या होगा कि गैस ने काम किया तो उसकी एनर्जी कम हो जाएगी. एनर्जी कम होने का मतलब क्या है कि काइनेटिक एनर्जी कम हो जाएगी. काइनेटिक एनर्जी कम होने का मतलब क्या है, टेम्परेचर हमारा कम होना चाहिए था, ठीक है ना. लेकिन यहाँ पे ये तभी पॉसिबल है, ये सब चीज़ें इंटरनल एनर्जी की बात हम तभी करेंगे जब हम उसमें इंटरमॉलिक्यूलर या अट्रैक्टिव फोर्सेस की बातें करें. बट आइडियल गैस बोला है तो उसमें क्या हो रहा है कि नो अट्रैक्टिव फोर्स इज देयर, राइट. एंड देयरफॉर जब कूलिंग होगी मतलब इसमें जब हम इसको एक्सपैंड करेंगे तो उसमें कूलिंग ऑब्जर्व नहीं आएगी. गॉट दिस. सो इट इज जस्ट they are moving because the space of the dimension has increased. Got this? However, the force initially was 0 and finally also was 0. Therefore, no cooling occurs. So, answer for this question would be B.